to present the work entitled A Low-Cost Microcontroller Acquisition and Remote Monitoring System for Photovoltaic Data Analysis. This work was developed by Professor Neil Cunha, as well as the students Jefferson Fernandes and Jefferson Barbosa. All the authors are from Federal Institute of Education, Science and Technology of the state of Ceará, Campus Cedro, Brazil. So this is a summary of our presentation. We will introduce some concepts of solar energy. We're going to contextualize worldwide and show a little bit of the Brazilian scenario. We're going to discuss about the proposed system, considering also the acquisition and the monitoring part of the system. We're going to show the results we obtained during our experiments, and we're going to discuss a little bit about them. And on the final slides, we're going to conclude the work. So the usage of non-renewable energy sources has represented a great impact in a negative way to the greenhouse layer. The usage of energy sources based on oil, natural gas, and even coal are not considered renewable energy fuel resources. That's one of the reasons we are considering use the alternative source of energy, including wind energy and in this case solar energy. So reforestation of previously cleared land can help sequester some of the carbon dioxide in growing biomass. So if you're worried, if you're concerned about future generations, we need to be concerned about the usage of renewable source of energy. In this case, we're working with solar one. So the use of solar energy has been used worldwide. There are a lot of countries that are working with this, and Brazil is one of them. And it represents a clean, green source of energy, and it becomes a great way to reduce carbon footprint, which is it's one of the greatest enemy of the greenhouse layer in our planet. So not only the solar energy, but also wind energy and even different types of alternative energies are welcome, and due to geographical reasons, due to the position of the country, in this case of Brazil, that's one of the reasons we decided to work and to develop a system based in which context is the solar energy. One of the greatest challenges that we face when we're working with the solar energy context, it's the monitoring part of it. So efficient photovoltaic panels monitoring reveals to be a great challenge, and that's one of the reasons we are proposing the system. It's the way to avoid an in-contact watching to the operator needs to be developing, including in our case a low cost of technology. If we're going to compare to the recent technologies we have, they are all basically high cost, and which turn the monitoring task even harder. So our idea is to propose a system that can be accessible, that it is not expensive, and used not only for commercial reasons but also for educational ones, as we're going to see in the conclusion of this work. So let's talk about the solar energy in the Brazilian scenario in the context worldwide. In the year 2016, the market of photovoltaic panels has broken several records again and continues global expansion. As we're going to show in the future slides, the years of 2015-2016 has represented a growth of 50% in the market to at least 75 gigawatts of the power. Although we have countries such as Brazil that are privileged due to its geographical position, the leaders on the production of photovoltaic solar energy in the year 2016 are still countries like China, Japan, and Germany. So this graph shows a little bit of what I said before in terms of numbers. So if you take a look at the years of 2014, 15, and 16, we're gonna see the growth that was mentioned before, and specifically the years of 2015 and 16, we have the 50% growth, and then the market and the evolution of the installations of photovoltaic panels in this case. Although our test was based on photovoltaic modules, a photovoltaic panel can be considered as well and will work properly. So, talking a little bit about the Brazilian scenario, Brazil has a geographical position that contributes a lot to the development of solar energy. So, it has a significant potential for energy generation from solar sources. The levels of solar irradiation in Brazil are higher than in countries that nowadays are the leaders in the solar energy related projects. And these countries include not only Germany but also France and Spain. So from now on, I'm going to talk about the system we developed. The system is composed basically by two parts. The first one we call it DAU, which one it stands for Data Acquisition Unit, and the second one for Data Monitoring Unit. The system is based on the acquisition part of the data, of the variables that are sent. They're collected from the photovoltaic module or photovoltaic panel, and they are sent to the data monitoring unit that can show it in a graphical way, as we're going to see in the future slides. So in order to perform this kind of graphical analysis, the data acquisition unit and the data monitoring unit, they developed a wireless communication, and the photovoltaic panel is attached to the data acquisition unit. So the variables, as we're going to see, the temperature, the voltage, and the current of the panel, they are sent using a Bluetooth communication to the mobile application we developed using the Android platform. So the operator can check the panels or the modules health without an in-contact watching of the panel. So the idea is to avoid a direct contact with the panel or with the module itself, and provide all this possibility without a high cost of acquisition. So here we have a table that shows the price that we spend, the cost we have in the development of the data acquisition unit. So basically have a lot of components, but basically have a microcontroller, we have a sensor, temperature, it consists of an LM35, and we also are using a Bluetooth module in order to perform the communication between the data acquisition unit and the data monitoring unit. We're using some current divider and also a shunt resistor to perform the current part, and the voltage divider in order to provide the voltage part of the graph. And all this analysis can provide for example, the analysis of the power of the panel, and all of this cost us less than $25. So the data acquisition unit as a whole was developed by approximately $23, which proves that our system can develop the analysis we're seeing in this presentation for a cost that can be accessible to everyone. And that's one of the main ideas we are working with this kind of project, with this kind of technology. So here's a picture of our data acquisition unit. It consists of an 18F4550 pico microcontroller. We're using a HC06 Bluetooth module and a 16 segment display in order to check if what's going to the data monitoring unit is really obtaining for the data acquisition unit. We are also using a voltage and current divider, as I said in the previous slides, and we have a lot of components as resistors and keys and so on. In order to perform our experiments, we using a SolarX photovoltaic module, and this has the following characteristics. So we have a dimension of 1.10 meters to 0.53 meters, an open circuit voltage of 20.5 volts, and a short circuit current of 3.75 amperes, which gives us a maximum power of 41 watts. And during our performance, we developed tests considering not only a sunny day but also a cloudy day, and we could analyze the variations that the weather could perform in our analysis, and we're going to show this in the future slides. From now on, we're going to talk about the data monitoring unit, which consists of an Android application. So basically, operator, it sets the frequency value and it wants to operate considering the voltage and the current, and also the time the system should work considering the kind of service. The system should operate and collect the data from the data acquisition unit in order to perform a detailed analysis or considering even a panel configuration. We have three different ones, but in this case we consider just the 25 and 2 amperes for 1 minute of frequency and time of acquisition. For now I'm going to talk about the results and the discussion about them. So the first graph, in this case we're just considering this one, is the voltage graph. It consists basically on the samples we collect during this 1 minute, and so we have the values from the voltage, we have the time, the date specifically, and also have the time when the sample was collected. The same graph can be illustrated, can be shown for current and also for the temperature itself, and so the operator can analyze the timestamp and the voltage specifically in the value, in this case the voltage, but the value specifically for each one of the samples that are collected during the analysis time. So it's just a proof that the data acquisition unit is working properly, and consider the measurement errors. And we could see that the errors in this case are almost zero. We have a 0.3056 amperes. They're measured by the data acquisition unit, and the multimeter is indicating 0.35 amperes, which shows that the system is working properly with a very short measurement error. So a little bit about the discussions of our results. We can analyze that the measurement errors of our data analyzed and considering the current, voltage, and temperature worked as expected. As I said before, we have these errors: 0.002 amperes for current, 0.25 volts for voltage, and we have a 0.1 degrees Celsius, which is the measurement unit in Brazil for our temperature analysis. The mobile application allows the variables to be properly stated. In this case, we just shown the voltage, but the current and temperature work in the same way. The instantaneous power could be extracted by the current and voltage analogy, just multiplying both of the variables. And for higher levels of charge, we could see that the voltage decreases considerably. As I said, we are just considering not only a cloudy but a sunny day, and depends on these cases, we have difference on the graph, on the values itself. The system has shown to be sensible to radiation levels. As I said, we considered basically cloudy and sunny days. In this case, you could see a variation due to the charge that has come to the photovoltaic module we used. The Bluetooth communication represented an efficient choice, considering a short distance. In this case, the maximum was 50 meters. But in our case, we do not have to be worried about the noise and the external interference that might be required if you're considering a Wi-Fi module, although we intend to use them in the future. So here are the conclusions of our work. The temperature, the current, and the voltage, that are the variables we analyze, could be properly illustrated in a graphical way, and also we could see on the data acquisition unit. The costs to develop the data acquisition unit endorsed the usage of the proposed system. We could see that with less than $25 we could develop a unit that can acquire temperature, voltage, and also current, and show and display it in a graphical way using an Android application. And as I said before, the system seems to be market-based, but our final idea is to use them in educational purpose. Our idea is to bring the students to show them the importance of consider alternative sources of energy, consider solar energy, wind energy, and the system has its final goal to show the importance of using renewable energy, basically, if we're thinking about the future of our generation. So that's one of the main goals we're trying to achieve with this project that we developed. We'd like to say thankful to the Federal Institute of Science, Education, and Technology of Ceara, Campus Cedro, for the support for access the labs and the equipments we need to use for developing this work. for your guys' attention. We'd like to say thank you very much.